right, good morning. As Aaron said, my name's Cameron Cochran. We are going to be talking about cast-in-place decks here. Now, the majority of the information, a lot of this information I'm giving you is the contractor's responsibility. So why am I bothering to go through this for you? I want you guys to know when that contractor is setting that screed up, I want you to know if he is doing it correctly. If he's when he's putting his deck pans in, overhangs, anything like that, I want you to know if he's doing it correctly. And there's several reasons for that. I thought on the first bridge that I ever built, I walked out, see this big yellow machine, I see the contractor setting it up, and I thought he knew exactly what he was doing. As the more I learned, I realized there were some things going on that were not correct, and we'll talk about some of those things. So just like we don't know exactly every single thing that we might be supposed to do that the contractor might expect us to know, they might not know it too. And I want you guys to be able to spot it if they're doing something that goes against what we're talking about. And the reasons for that is maybe later in the process, if you start having trouble when you're finishing, maybe you can figure out what's causing that and make some recommendations. If it gets really bad and you have to call Aaron, you can tell him how they set it up or how they deviated from the instructions, and that may help him identify what's going on. And we're going to be talking about a lot of things that are basically rules of thumb. And you're not out there to set him to the quarter inch on this thing when on some of the measurements that we're talking about. But you should be able to have a conversation with him and ask him why he set it up differently from what you have been shown, and he may have a good reason for some of this. I'm not going to tell you how anybody else sets it up except how the manufacturer says to set it up. You got three different types that you will run into, either a Bidwell, a Gameco, or an Allen, but all these principles apply to all three of them. So, let's get into it. If you have never been around one of these things, real quickly, I want to go through the words I'm going to be using so you'll know what I'm talking about if you've not seen one. That is the screed truss. That's the backbone of the whole thing. This is the carriage. That's the business end of it. This is the leg, and if you look right back here, you can see the top of the second leg. You got a leg on each, both sides, 4 legs in total. And right back here, you've got the work bridge. Work bridge normally runs on the same rail as the screed. Now, if we zoom in a little bit on our carriage, first part up here is the augers. This is the vibrators. These are the drums or the rollers. This is a drag pan, and this is a burlap drag. Those are the normal parts that you're going to see on this machine. Two of the terms that we're going to be talking about in depth a little bit later are the carriage rails. Now you have 2 carriage rails, one on each side of the screed truss. And you also have the screed rails. Both these are important, especially the screed rail, so we're going to spend some time in depth a little bit later talking about those. All right, somebody tell me, what is a buildup?
Your numbers off your girder.
The what?
Your numbers off of your girder.
It's a distance. What does that distance represent?
Theoretical at first, and then you go into, you got physical shooting.
That buildup is basically the difference in elevation between the theoretical bottom of the deck and the top of the deflected girder. It's right here. Now, you see in this situation, you're on super elevation. If you've got a normal crown or a flat slope or a narrow girder, you may just have one buildup right down the middle. If you're on super elevation and you've got a wide flange girder like a bulb T or a big plate girder, you'll probably have an elevation on each side. So you may have 2 buildup measurements at the same buildup point each time. Now, all through this, we are going to use that buildup like a little benchmark. Everything that we're going to check, you guys need to check it back to the buildup. You don't want to check it off of something that was set off of the buildup or something that was set off of something that was set off of the buildup, because you run the risk of having compounding errors. So after they shoot the buildups, what's the first thing happens? Somebody comes in, starts putting down metal decking, right? Now, do you think those guys get that exactly right everywhere they weld that angle? Probably not. So if I set something off of that metal decking, I've got a good chance there's another error there. I saw a contractor one time that took a big straight edge and he set it across the top of his metal decking, and that's what he used to set his overhang elevation. So there's two places you could have an error. Then he measured up off of his overhang to set a chamfer strip. There's the third place you could have an error. And then he measured off of that to set his screed drill. So you could have compounding errors if they're all in the same direction that could lead to something significant. So when you guys check them, check everything you check off of your buildup, off of your little benchmark. All right, this is a screed drill. This is the most important factor in the ride of that deck. What are the two things the public cares most about? How does it feel? How does it ride? And how does it look? Darren's going to take care of concrete finishing. We're going to take care of the how it looks part of that. We're going to fix the ride part right here. These cups. Can somebody tell me if I make a complete turn of that nut right there, how much does it raise or lower? A quarter inch. So if he's making adjustments during your dry run, you can count the turns and you can know exactly what he's doing. One more thing to notice right here. Look at this. The rail's not setting all the way down in the saddle, all the way down in the cup. What's going on there? Rail may be bent. Or it could just be the weight of the screed is not on it right there. Maybe bowing it a little bit. When we're doing our checks, when we're doing our dry run, the screed needs to be where you are. It is. If you pull that screed down to that area right there, it'll be down in the cup. So that's where they need to be when you're setting, when you are doing your dry run, anything like that. Now we're going to go through machine setup. There are, Darren's got some cards he's going to give you, and we're going to go through these steps. Step number one, read the owner's manual. Every one of these machines comes with an owner's manual that the contractor has got somewhere. You can download that owner's manual. I've got several of them here that I have downloaded that I carry around for my personal use. The example that I have been using, my son, the last time we taught this class, was 4 years old, and he couldn't read. But when he got a set of Legos, first thing he did, dump them out on the floor, fold out the directions, and he would follow those directions. Couldn't read, but he could follow those directions. In a few, 30 minutes, he had the same thing that was on the box. If he can do that and can't even read, we can do that too. All this is following the directions. Okay, the first, if you look at that card, you see on the front side, it's got your the 6S list. That is the 6 steps that we're going to be going through right now. For the first 5 steps, we want the carriage to be in the center of the truss. Now, when you stretch these out and get into a longer pour, like 100, 120 feet, something like that, there's a lot of bounce goes on in that truss. So you want to have that carriage in the middle of the truss, and you want to have all the attachments on it while you're doing these steps. So you get that maximum deflection like you'll have during the pour in that truss. Now the last step, we're going to move that carriage. But for now, the first 5 steps, that carriage needs to be right in the middle with all the attachments on it. Okay, there's your card. And if you follow the directions, you're going to eliminate the vast majority of the problems that can pop up. Okay, getting started. What's this guy doing here? You can read the slide and nail it every time. He's squaring the legs. So what is he measuring? What distance is he measuring there? He's measuring from what to what? He's measuring from the screed rail to the carriage rail. Now, the distance that he gets right there doesn't really matter. What you really want to see, though, is the front leg and the back leg need to be the same on this side of the screed, and they need to be the same on this side of the screed. You may have a different setup if you're like on a latex overlay or something like that. You may have something where the leg is hanging off the barrier rail, like you see in this section, or you may have something where it's sitting on cups directly on the deck. So one side may be different than the other, but that front leg and that back leg, both of those need to be the same. We'll change that a little bit later, but that's where we want to start off. All right, this is how you adjust that. This is one of the older ones, looking down from the top. Anybody want to take a hazard to guess as to if I make one complete turn of that leg, how far does it raise or lower the screed? Quarter inch, again. Always make sure there's a locking pin in it after they get those adjustments done. One of the things, well, let me get this right quick. This is an automatic one. The automatic adjuster here, the man on top here can control, he can run that leg up and down. The newest models, kind of like a concrete pump, they've got the remote that sits in front of you here, and you can run the whole thing off of it. One of the things that I like to do is, regardless of which one, if I'm the one that's out there responsible for this, I want to take a Sharpie and I want to go to where that leg telescopes. And after they get done adjusting, I'm going to make a mark on the bottom part of that telescope so that if I come in later and I see there's a gap or I can't see that mark, I know somebody's done something to the screed. I had one contractor that would actually put a padlock in the front legs instead of a pin so that he was the only one that could make that adjustment. But big thing is you just know what's happening. Okay, what's this gentleman doing? Read it. Straightening the truss, exactly. Now, when the screed comes to the job, you're probably going to have 2 or 3 sections on a flatbed. And if you've got that 100-foot pour that I was talking about earlier, they're going to have to add sections into that. And when they add them in, there is at the bottom, these are all pin connections. And at the top, you have an all-thread connection. This one's actually got a manual crown adjuster, which we'll look at a little bit later. But this one doesn't have to be very precise. You can sight down the truss to make sure that it's relatively straight. The next step is where we're going to get a little picky. But this one, you just want to get relatively straight. All right, what's this gentleman doing? Yes. At each end of the screed truss, there's a big plate, and there's a slot in each corner of that. There's supposed to be an eye bolt in that slot. So what we're doing here is, if you look, he has got a 2x6 here, or something, and you notice the dressed edge is up, and the cut edge is this way. You cut 5 blocks. The other 4 blocks you're going to take to the corners, and you're going to wedge it in there between the carriage rail and the string, all 4 corners. He's going to take this block, and that's what he's going to use to set the carriage rail. They loosen a couple of bolts right here, and this gentleman up here with the socket is going to raise or lower that carriage rail until he just barely passes that 2x6 underneath the string. You go all the way down one side, come back down the other side, and you ought to have a carriage rail that's straight as a gun barrel. Now, what does the carriage rail determine? We determine that the screed rail is going to determine how that bridge rides. What does the carriage rail do for you? It determines your cross section. Now, you may not feel deviations in the carriage rail because you're running at a 90 to it, but it can affect, it's especially if you get on a pretty flat deck, it can affect where your water runs. It can cause other problems. So we want to check this. And again, where's the carriage during all this? It's in the center of the truss, exactly. You can even come back after you do that and take your 10-foot straight edge and run it down the carriage rail just to make sure that you don't have any bobbles or anything in there. Now, if you look on the flip side of that card that you got is another QR code. As Aaron said, you're going to be getting a lot of information over the next day and a half, and I don't expect, especially if you're new, don't expect you to remember all that. But what I do, I don't even care if you remember my name, but remember that guy with the weird mustache has got a QR code, and he told me about that, and there are videos on YouTube that I can go to that will give me the Cliff Notes version of all this stuff we're talking about. There's a lot more on there than that, but there's like 40 videos. You will also have, we're going to make available PDFs of this presentation. We're going to have the presentations recorded so you can go back. And also, you've got Aaron and Aaron, or even me and Darren. Call somebody. They are much happier going out to your job and spending some time with you looking at this stuff than they are being in a meeting. So don't be afraid to call them. You're not going to bother them. But you've got the resources. So if in 2 years you've not touched a bridge deck and the contractor shows up with a screed or whatever, you know, hey, I've got some information that I can go back to. And in 15 minutes, there's 4 videos that are going to show me the Cliff Notes version of all this stuff we're talking about on this machine setup. This is one of the videos. I'm not going to show it. I'm going to go to something else. Okay, string lining the rollers. This is the most neglected step in setting a screed up that I see. And what a lot of times you will hear is a contractor says, I don't need to do that. I just used a screed down here and it was fine. My example is we were pouring a deck in Canton, doing an overlay on the cord slabs. And the contractor, I got there for the pour, the contractor started off, he gets out on the deck and it's making a big mess. And I started asking him the normal questions that I ask about how he set the screed up. And I got to this one right here. And he said, I didn't need to do that. We just used a screed in Bryson City, and it was working fine. So he goes a little further. He's like 15 feet out on the deck. Still a big mess. So I finally made him stop, pick up, back off the deck, and we checked through the checklist, and we got to this part right here. And what we discovered is one of the drums is tilted this way. One of the drums is tilted this way. So one's tearing up everything the other one just did. Making an awful mess. It took about 5 minutes to do these adjustments that we'll see on this video. He pulled back out on the deck and it finished like a dream the rest of the way across. So even if the contractor doesn't do this, you guys should be checking it. He ought to help you check it. String lining the roller. So what's going on here? If you look up top, you see a string line right here. This string line, we've already done our legs, done our carriage rails. They've taken a string and they'll go on each side of the carriage and they'll pull a string between the carriage rails, pull it tight. And he is measuring down, in this case he's measuring down to the top of the drums. What you want to see, whichever method he uses, is an equal distance at all 4 corners as you work your way around those drums. As you change one, it'll change the other side just a little bit. So you may have to make 2 or 3 passes around there to make that equal, but you want an equal distance. At the same time, while you're doing it, check right here. This is a skew ring right here, and make sure that it's not loose. I've seen them where that was wobbly and it will show up. I like this better, and what you can see here, the contractor has put his straight edge on the bottom of the drums. So you have a straight edge on the front edge of the drums on the bottom, hold it up with some bungee cords or something, and on the back edge. And you go around to all 4 corners and measure and adjust until all 4 measurements are equal. Now, depending on which method of dry run you use, that's an important measurement, so write it down. Again, depending on which method you use. That's going to be the C dimension if you use the dry run procedures in the construction manual. This is a little bit better picture. You see the string line going across the carriage rail up here. And you see he's got his 2 4-foot levels snugged up underneath the drums. All right, what's this gentleman here doing? He's vibrating, and which way is he walking? I bet you $20 he's walking this way, vibrating it and walking right back through it. What we would ideally like to see is him vibrating, walking himself back out of it. That way we don't have these unconsolidated places in the footprints where grout's going to get flopped over in it and a potential pothole later. So that's what this is for. That's the vibrator. It's a basically all it does is vibrates the top couple of inches of concrete. Now, it's not a required thing on the contract, but if the difference to me is if they have this and it is functioning, I don't worry about them walking in it so much. They can walk in it and I don't worry about if they go back and revibrate, because that's going to do it. If they don't have it or if it's not functioning, then I'll keep on about going back and vibrating the footprints out. And we'll go through some of the settings here in a little bit, but about the elevation that you set that to in reference to the drums. Now on a skew, if you end up on a skewed pour, these can cause problems, because the only thing that makes that vibrator turn is just the friction between the deck, the concrete, and the roller. It just sits there and vibrates, and as you pass, it's rolling across the concrete. If you get on a skew, it starts kind of dragging, and sometimes you may have to even pull one of them up to where it's not even touching and just have one drum down, but 90-degree pour, they work just fine. All right, this video I do want to watch.
Transverse screed setup video 2, aligning the rollers. This is the second video in this series. The videos should be watched in order and the procedures shown should be performed in the same order. The next step in the process is aligning the paving rollers. The rollers should always be checked each time the screed is set up. On a skewed deck pour, the lower carriage should be placed on a 90-degree skew at this point. Skewed decks will be discussed in more detail in a later video. One 4-foot level should be strapped perpendicular to the front edge of the drums and one to the back edge of the drums. The easiest way to accomplish this is with bungee cords. This diagram shows the straight edge flush against the bottom of the drums as well as the string line drawn across the carriage rails. Next, the string line is stretched perpendicular across the top of the carriage rails. Measurements are taken at all 4 corners of the drums, from the string line to the top of the levels. The drums are adjusted until the measurement at all 4 corners is equal.
Alright, well, let me check one.
To adjust the roller height, first loosen the bolts holding the paving roller bearings. The rollers can then be adjusted up or down until the measurement at all 4 corners is equal. Remember to retighten the bearing bolts when you're finished. Next, if the screed is equipped with vibrators, their grade should be set. This grade is roughly 1/8 of an inch below the front edge of the rollers. The initial grade of the auger should be set 1/8 to 1/4 of an inch above the edge of the drums. On this model, the augers run between the vibrators, so a string is pulled up to the bottom of the vibrators and the auger set 1/4 inch above the vibrators, or 1/8 of an inch above the rollers. Auger height is set with this adjustment or a similar one on other models.
Okay, so that video is like 2.5 minutes long. 2 years from now, like I said, if you haven't seen any of this since then, you can sit down in your truck with the iPad, and in 15 minutes you can go through every bit of this setup stuff. You got a refresher course right there. Okay, what is this gentleman doing? He's setting the crown. If you have a crown in your deck, this is where you put the crown in it. These are the normal connections with just an all thread. This is a manual crown adjuster, which we'll look at a little bit later. You got basically 2 big sprockets, 2 little sprockets, and 3 chains. If you have a mean designer and he has designed your bridge such that you're transitioning from a normal crown into a super elevation, then you're going to have to change the crown in that screed as you go along your pour. What this does is allows this guy to stand here in the concrete you haven't finished yet and adjust both sides of the truss without walking in the good concrete or crawling around on top of the truss. And much like the automatic legs, they have automatic crown adjusters where the guy could be adjusting it on the remote control. Now, how do we set that crown in there? How do we figure that? It's not too bad. So we know what our rate is, our crown rate. We know that the distance from our leg over to the crown, and we can figure that. So that's what Kevin's done here. He's taken a picket and he's figured out how much higher should that crown piece be, that crown joint be, than a string line pulled along my carriage rail. And he is telling the contractor to lower that until he hits his mark. It's as simple as that. So what we're doing, we're taking that rate right there and we're figuring it 40 feet over, and you come up with 0.8 feet. So if I pull that string line there, the crown joint in that truss should be the same measurement. All right, what if you end up with one that's not symmetrical? What are you going to do there? What's the math involved in that? I'm going to use the same thing, and I'll tell you how I'm going to do it. I'm just going to, if I've got 20 feet on that short side, I'm just going to measure out 20 feet on the other side. Make the same calculation. This part of the screed is going to follow whatever this one does, and especially if you end up with, it just simplifies the math. Don't complicate anything more than you have to. There's your, that's the little bit better picture. This is the adjuster that you see in every section, and the manual crown adjuster you see over here on the side. Okay, 5 steps we've been through. Where has the carriage been that entire time? Center of the truss. Remember that. Now, for step 6 and for the rest of this, that carriage is going to follow us around. We want the truss sitting where we're checking, and we want the carriage rail, we want the carriage right beside us the whole time. How's your contractor set that machine to grade? We've got the legs equal, carriage rail straightened, we've got the drums checked, we've got all this stuff done, but how does he set that machine to grade?
Nuts under the rail.
What?
The adjustment nuts under the rail.
But where's he measuring to make sure it's at the right grade?
Build it.
Go to your first buildup. So he is going to pull this carriage over here to the exterior girder. And he's going to pull it up to where the front of the drum is right over the buildup point. When I measure down from the bottom of the drum down to that buildup, what should I read? What? Thickness of the deck plus the buildup. So if he's a little bit low right there, he's going to raise both legs the same amount until he gets to the deck thickness plus buildup. Then you pull your carriage over to the other side, the other exterior girder, and you're going to do the same thing again. Now, at that point, he's set to grade. At that point on the rail, he is set to grade. How do you see your contractors setting the header elevations? Because up until about 2016, we gave header elevations in the printout. We asked structures to stop doing that. Now, why is that? Okay, that first deck pour I was talking about that I ever went to. At that time, we got those header elevations, and the contractor set this header to that elevation, and he'd leave you the 1/4 inch load, and then he'd go across it, and at several places he would drive some nails and leave him sticking up 1/4 inch. And when he did that dry run, if the drum squeaked across the nails, then that was great. That's what they were looking for. I don't like that. I like this. So what do you see right here? He's got a string line set up, but he's got a 2x4 there on top of his header. I want the header to be low. I want the header to be a couple of inches low. Because what you would see when people were setting the headers at a 1/4 inch low, like I was just talking about, After the pour starts, a lot of times that first few feet you end up with sort of an open pitted finish, and somebody's got to go back with a trowel and work on that a little bit. That guy is tempted to finish down to the header if you don't watch him. And if he does that, you got a bump, and you're going to always feel it. We're taking a lot of time here for me to tell you how the company says to set this thing up. We want to let it finish the maximum amount of the area of that deck as possible without us having to touch it. So I want to leave that low. Sometimes you'll see contractors will have a little extra plywood to let the extra concrete spill out on, but just let that thing ride. And that way the guy's not tempted to finish down 2 inches where he might be tempted to finish down 1/4 inch, and you will end up with a better ride. In order to assure that, this needs to be you. As soon as that pour starts and they get that carriage far enough ahead to where you can get that straight edge out there, you need to be laying that straight edge down, and you need to be checking to make sure everything's right. You need to be making sure nobody has finished that header down. The other place that you need to be using that straight edge is right over here. Now, the guy that finishes the gutter causes us trouble in a couple of different ways. First way is what we want to see. This, the screed can't finish all the way over to that side form, so we've got to have some hand finishing there. But what you want to see is they're continuing the rate that the screed is cutting all the way over to that side form. And in order to do that, he's got to have a straight edge, and it needs to be longer than he can reach, because he can mess it up as far as he can reach. So get one longer than he can reach, set it down there, and make sure he's carrying that rate all the way over to the side form. Now we're going to be talking about, tomorrow you're going to be talking about shafts, things like that. We're talking about decks here. Where is the lead inspector? Lead inspector's out here on the deck with the screed watching what's going on. You don't need to be worrying about the pump. You don't need to be worrying about samples, slump, stuff like that. Engineers, you need to have enough guys out there where you didn't have to do that. There needs to be somebody else taking care of that stuff. Your attention needs to be right out here, because you're the only eyes we got, and when you call Aaron with a problem, you need to be able to tell him what was going on when this happened. This is what happens if you don't. Now, what is the problem here? What's this going to do to us? Yeah, water's not going to go where it's supposed to go. Now, if you're a hydraulics engineer, there are 2 boogeymen that keep you up at night. One of them is spread and one of them is scour. This can affect spread. If that's bad enough, it can force water out toward the lane and cause spread out into where the traffic's at. Now, we do not want that. It'll also cause a bird bath on either side. If he finishes low right here, it'll cause a bird bath right there. And you got salt water just sitting there soaking. So pay attention to this. Make sure they know you're going to check it and keep an eye on it. This needs to be you. And you can see right here, this is they've laid a piece of plywood out, and they've done just what I was talking about. They've got a couple of inches extra concrete sitting there. They'll come back in the next morning, uncover that end, take a quickie saw, zip that lip off, and you're ready to go. What happened here? If you guys follow these directions, if you go through these steps and you do the dry run like we're talking about, you should never see this. But my predecessor told me one time, and I have always remembered it, we can fix just about anything, but you will never end up with as good a job fixing something as if you had built it right the first time. This is a patch. It will always be a patch. They're going to have to come in here and patch that. It'll always be a patch. It'll be a maintenance problem. But if we build it right, you wouldn't be worried with that. So take the time to check all this stuff. This is an example of something that's easy to fix while it's green, and they set that header just a little bit low, but check it. It's easy to fix while it's green. If we've got to come back in later and try to fix something like this, it's going to be expensive, it's going to be a patch, and it's not going to last as long as if we'd done it right the first time. Okay, now I'm going to get into some rules of thumb in setting this machine up, which is just, I'm not going to fight a contractor for not following these rules of thumb, but I'm going to pay attention to what he has done. Because what's our objective here? What are we wanting to see when that screed pulls off the other end? We want to see a good deck that's finished well to the proper grades, right? If he doesn't follow the steps just exactly like I'm talking about, but he is producing a good finish to the grades that we're looking for, I'm not going to mess with it. I'm not going to say, no, you don't have a golf ball size roller grout in front of that roller. I'm going to let it run. And if it's running good and it's finishing good, I'm not going to say a word to it. If it starts finishing bad, if we start having problems, that's when I have paid attention to how he has set this thing up, and I go talk to him about it and see what adjustments will we make to fix this. Okay, all of these rules of thumb here, we're going to be referencing this point right here. That's the business end of the drums, the front finishing edge of that drum, and everything else is set in relation to that. So the first thing you see out here are your augers. The augers are supposed to be set 1/8 to 1/4 higher than that reference point, that front edge of those drums. When you check them, you need to be checking right back here at the back end of it, because if you've got a real old set of augers, over time that front end's doing most of the grinding, and then they'll actually turn into Christmas trees instead of cylinders. So that front edge may be a little smaller in diameter, and if you set it to that, you may have to make some adjustments because you're not getting enough concrete. So always check the back edge of that. Rotovibes we talked about a minute ago, they're supposed to be set at grade level. They've got ridges on them. The land in between the ridges is the part you want at grade level. You want those little nubs sticking down in the concrete just a little bit. And again, it's to vibrate that top couple of inches where people have been walking in it and things like that. All right, back end, we want it 1/8 of an inch above the front end. Now, I just said we got all the legs and everything squared up, things level. Where does that come in? What?
For the finish,
Well, when do they do this?
that should be your initial setup.
Well, what I see contractors do a lot of the time is they will wait until the pour starts. And once they get those drums out on the concrete, past that header, then they'll take the back legs up a half a turn or so. Sometimes they'll set it before, but that's what you want to do. The one thing I want you to remember about that is that when you are cranking this leg up here, it's basically pivoting around this point right here. So when I raise up this back end, what's happening over here? I'm making the augers go down a little bit, right? So just bear in mind, the two most common adjustments a contractor is probably going to make during a pour is either raising or lowering the augers or raising the leg in the back. So just realize that raising that leg also affects you in the front. Pay attention. Now, when a contractor makes a change, when they make an adjustment, how long do you think he should wait until he tries something else? He's got a bad finish and he's going to raise his augers. How long does he need to wait until he tries something else? Say 4 feet.
4 feet.
About a drum length. Because if I go in there and I make an adjustment and that screed makes about 2 passes and I say, oh my, that's not working. And I make another adjustment and I go a couple of passes and that's not working. I make another adjustment. All of a sudden, when you get out there to where you can actually see the effect, you don't know what you've done. You don't know which one of those adjustments did what. So you want to go like a drum length before you make another adjustment or decide what did I just do. Make life a whole lot easier. And if you mess up, there's nothing wrong with backing that screed up and hitting it again. Nothing wrong with that. I've done it plenty of times. All right, this is our drag pan, and you want the drag pan hangs from a frame with chains. You want it to have some slack in it, and the only thing really to look for on that, there's bars on the top that the chain's attached to. Those bars need to be pointing in the direction that that pan is moving back and forth. They don't need to be running with L. They need to be running transversely, or you can end up with a pan digging in or something bad happening. All right, this we saw in that video. This is the this right here is the adjustment for the auger height. Now, what's wrong with this picture? He doesn't have a pin in here. Now, you got this machine sitting there running, banging around. You got a set of vibrators right underneath that, vibrating. What's going to happen if you don't have a pin in it? Those augers are going to try to go down. So always make sure they've got a pin in the hole. Some of these, you have some models that shaft goes all the way through to where you can adjust it from either side. Some of them, the shaft is vertical. But the big thing is, once you adjust it, make sure you put that pin. Somebody has put that pin in there to keep it from moving after you've adjusted it. When you, so that's your vibrator adjustment. I said if the contractor has one and it's functioning, I don't worry so much about the footprints, but make sure it's functioning, because I have walked up to them before and stuck my toe to the vibrator and it not do anything. They have to have it turned on. And that's what this lever right here is for. So when they get everything cranked up, go over there, stick your toe to it, make sure the thing's actually functioning. When you stop, and I know y'all don't have any problems with concrete delivery, so this probably doesn't apply to you, but if you have to stop and wait on a truck, if you're sitting there for 30 minutes, don't just let that thing keep grinding away. They're up above this, there's a lever. You can hit the lever and take the carriage out of gear. You don't want those vibrators and drums just sitting there on the same spot vibrating while you're waiting for something. Okay. This is how much concrete those augers are supposed to push. Now, if you go out on a deck pour, there's a bunch of guys out in front, 4 or 5 guys, and they got a rake in hand. And it's like they think, if I don't rake, somebody's going to jump on me because they gave me this rake to use. And they rake and rake. And then they push because they pull too much out. And then they rake, push, rake, push. Try to get them to leave it alone unless you start building up to like auger height. Because every time you pull it and push it, you're causing segregation. You got the potential to make it segregate right there. So try to get them to minimize that. It's made to push half the diameter. This is another rule of thumb. If everything's finishing right and they're not gouging down and pushing and pulling, then maybe it's okay. This is the golf ball size roll of grout that I was talking about earlier. And again, a rule of thumb. Each pass, each one of those finishing passes, it ought to be spitting out just a little roll of grout, maybe golf ball size in front. And that's our starting point. Okay, augers. There is a left hand and a right hand auger. If the purpose of the auger is to push excess concrete ahead, what do you think happens if you get them backwards? It's going to pull all that extra mix that back in, and it's going to flood your drums and make a mess. There are several ways that you can think of to make sure as soon as he starts that thing up, if he's got the right auger on the right side. And to me, I imagine like a barber pole. If you look at that bottom edge of that thing and it looks like it's moving ahead, then that's correct. If you look at the bottom edge and it looks like it's moving this way, then he's got his augers backwards. And you better tell him. The drums, you can set them to turn any way you want. You can set them to change direction that they're turning at the end of a pass. The only time that you would do that, or the only time that you would have them set up like this, both turning toward the middle, is if you're on a crown and you're finishing on a 90-degree skew. Now, what does the spec book tell us? When can you finish on a 90-degree skew? Between two skew angles, 75 and 105. If your skew is between those, you can finish on a 90. Outside of that, you're supposed to finish on a skew. Now we're going to talk about these bottom down here clockwise, counterclockwise. If you're on a skew, that's what you ought to see. It ought to be turning in the same direction throughout the pour. And we need to talk about finish and pass now. If you can see this, I've got my little arrows here. Both these drums are turning clockwise. So when it travels across that deck, it's pushing grout this way, spinning this way, pushing the grout this way. That is a finishing pass. Now when it changes direction, if the rollers are staying in the same clockwise pattern, that is a traveling pass. It's like a little car is just rolling back over the surface. So the finishing pass is pushing the grout ahead of you. The traveling pass is just walking back over what you did. Now that becomes very important on a skewed pour. I have given you some rules of thumb, but I'm going to give you a couple of rules that are basically set in stone. And the first rule is right down here. If I am standing on this pour and I'm at the beginning end back here, this is where the finished concrete is, and I'm looking ahead, this corner is farther away from me. That is the leading edge. This corner back here is the trailing edge. You always want that finishing pass to be coming from the leading edge to the trailing edge. Because if you, the example I always use, if you imagine that those drums are basically acting like a big squeegee. So if I take my squeegee and I move it in this direction, where does the excess water, concrete, whatever come out? Yeah, it comes out this side, right? Well, that's where I need grout. I've already finished. I haven't finished there yet. But if I finish back here and I take my squeegee in this direction, where's that grout coming out? Coming out over here where I've already finished. So it's leaving little ridges behind the drums that the pans are not going to take care of. So it's very important. That's rule number one. We don't break that. Rule number two is right here. The direction of the pour is important if the deck has a super elevation. What you want to do is finish up the super elevation. You want that finishing pass to go up the slope. If you have the finishing pass going down the slope, it's going to make a mountain of grout in that low gutter line. Now, where'd that grout come from? All the rest of the deck. So you will probably end up with an open pitted finish, plus you got this big mountain of grout that guy's having to rake ahead, just pure old grout, no aggregate in it. We don't want that. We want to push it up the hill, get a better finish, and it's easier on the guy raking. What do you do if you can't do both? In this example, what if this was the high side of the machine? This was the low side of the machine. If this was the low side and this was the high side, what do you do about that? We're going to phone a friend, call Aaron. We change these sometimes. We have done some classes or some presentations with designers over the past couple of years trying to emphasize some of the constructability problems that go along with different designs. And this is one of the things that we have tried to talk to them about, because they'll go in and they'll set a pour up to that Wisconsin pour sequence, and they weren't really aware of the problems that it could cause us during the deck pour if it was going the wrong direction. Now, if you had the situation I just said and you could, doing rule one meant you broke rule two, we can flip that pour direction around and that will fix it. That's not a monkey you want to take on your own back, but call Aaron and he'll look at it and see if you can swap everything. And the earlier you see it, the better. So we can get our pans laid in the right direction, all that good stuff. It'll flip where your construction joints are. So it's not just as simple as changing direction. There's a lot to it, but it's not that hard to do, and it will make finishing this thing a lot easier. The third rule, if you can make it, is finish down the vertical grade. That's not nearly as important as these first two rules in 99% of the geometries that you guys will end up with. Okay, now we're going to talk about dry run. If you've got an old hard copy of the construction manual, or if you've got the online version, if you go to engineering control, there's a section on how to set up a transverse screed. Everything in it still applies, but we've made improvements over the years to how we do that. Now, during that dry run, I like to see it in the workbook because I like something that will go in my pocket that's not going to run away. And I'm not going to lose pages out of it. I know that now you've got contract surveyors, and a lot of times all you get is a printout, and that's fine too. The big thing is you want information recorded in there so that it is plain and somebody else that comes up is able to understand what you've done. You want to have space in it, and if your contract surveyor is printing out those copies and giving them to you, then maybe you get him to put a couple of extra columns in there that are blank for your use, because we also want to record depth checks during the pour and cover checks during the pour. Now, we already established that there's various methods a contractor may use to set that rail to start with. And, you know, he can do whatever he wants to. He can do the thing with the compounding errors I was talking about. But at the end of the day, he's got to pass our dry run. And we're checking everything back to where? Back to the build-up point, our little benchmark. So he can set it however he wants to. That's just preliminary. We got to do the dry run. Now, after everything's done, you can read through this in the construction manual. But if you notice right here, we've already the distance I told you earlier that you could write down was this distance right here from the bottom of the drums up to the carriage rail. That distance right there, does that change? That never changes, no matter where you're at on that deck. This distance right here, what is that? It's my deck thickness. Does it change? No. So those two things are constant. That's just they don't change no matter where that carriage is on that deck. So your buildup is the only one of those three components that changes. Now, I don't like crawling around on things. I don't like crawling around on a rebar especially. And I'm going to do whatever I can not to do that. So I'm going to figure out if those two dimensions don't change, why can't I just measure from the carriage rail down to the top of the girder and figure out what that is? Now, during your dry run, you want to address this? Because you put that in there.
So, like Cameron said, you know, the C plus D here, that's a constant. That's not changing. So, during the dry run, if you use this method, which again I call it the sore back method. Basically, you're going to be putting your level under your rollers, right? And then you're going to get down and you're going to go over each build-up point, and you're going to measure to the bottom of the rollers, right? Your deck thickness plus your build-up, okay? And you're going to have your dry run book set up so that you already know what that theoretical distance is supposed to be, because you've got your build-up and you know what your deck thickness is. So at each point, you know what that's supposed to be. So during the dry run, you're going to go and you're going to measure that, right? And you'll record that. And there's going to be, it's going to be maybe a difference, or it might be exactly the same. So when we're going through our dry run, and Cameron's going to get into that a little bit, you'll have that recorded, and so you know what that is. So eventually Cameron's going to talk to you about making those adjustments so that theoretical and what you're actually building or measuring is exactly the same. Okay, so this is a method probably most of you are familiar with. We've been doing this for years, but it requires you to get down and read that level from underneath the drums down to that buildup. Okay, so call it sore back method because you're going to spend all the day, you know, crawling around down low. You have to also be careful, because if you look at it from an angle when you're measuring down, you can get a little bit slightly different measurement, right? We want to get very precise with that. So that's the sore back method. So Cameron, I'll let you kind of get into the smarter method.
Okay, so years ago, thinking about this, is like, there's got to be a better way. And that brought us to the stick. Now, if that distance doesn't change and that distance doesn't change, and B's all that changes, like I said, I'm going to measure from a carriage rail. And the first time I used a stick, what I was doing, I just took a piece of chamfer strip, and I took an old tape that had the end broke off of it, and I'd cut 2-foot sections out of it. And I would set that thing up on the build-up point, and they pull the screed up to where it's touching, the carriage rail was touching my piece of chamfer strip. And I would adjust that piece of tape until I read whatever the buildup was. If the buildup was 0.24, I would move that tape up and down until 0.24 lined up with the top of the carriage rail. And then I would tape it to the stick, and it was set. I could go wherever else. Now, over the years, I decided I was going to make my own stick, and I made this one. And basically all I got to do is I set this down on the buildup, I raise it up, and whatever the buildup is I'm supposed to read on the carriage rail, I get it there, I lock it down, and I'm set. So what all can you do with this thing? Is that all? It's more than one purpose. So we can set the grade of the screed from the buildups with this thing and directly read the buildup number, not have to do any math at all. You can also check some grades. Now, so if this is my deck, we're going to make the assumption that the girder elevation is right here. If this is my deck, I'm setting it right here to check my buildups. Then, if I set it on top of my deck pan, what should I read? No, I'm reading the buildup right here. So if I move it up to the top of my buildup, what should I read? 0. Because if I'm reading 0 right there where the deck is supposed to be, and I move it down here, then I'm reading buildup, right? So all I got to do is take this, set it to my buildup. I can check my buildup. Then I set it on top of the deck pan anywhere out there, and I ought to read 0. I can do a little math and figure out, all right, how tall are these bar supports, how big are the bars, and I can work my way up here. Or like Aaron said, maybe you take the deck thickness, you take the subtract the amount of cover you're supposed to have. You set it on top of your rebar, and you ought to be able to check your cover. So you would come down the scale to whatever that distance right there is, and you'd be able to check your cover anywhere you're at. So there's several things that you can do with it. Now, if you want to make one, there's video on YouTube tell you exactly how to do it. This scale, you can print that out. That is in the construction resources section of Connect, and Aaron can tell you how to get to that. But you can download this. Just make sure, if you print one of these out, make sure to check it with the tape so that you printed it correctly and the scale is right. And looking back through this, so that's what we're going to have. I've got here's my 0 mark. That should be set to where I can set it on top of the deck pan. I've made a mark down here somewhere, taking a pencil or a piece of tape and put it where I ought to be sitting when I'm on top of my rebar. And I ought to be reading the buildup on the top end of it. And that's what they're doing right here. Stand up, no crawling around. It's pretty simple. This is mine, and this is one that we just did recently. I've got a whole video of it where it just shows how quickly you can do it. Now, you guys are smart. We have smart inspectors, and I had an inspector kind of one-up me, and he comes up with this. So I go to a meeting, and he says, I'm using a distance meter to do my dry run, and I kind of give him the side eye. And I was thinking, in my head, I'm thinking about the rangefinders you use for hunting, where you're within a few yards, you're pretty good. I was worried about the accuracy of this. So he takes me outside, shows it to me, and he takes 5 or 6 measurements in a row, all within 1,000th of each other. So what he has done, he's taken a 2x4 and set it across the carriage rails. He's attached this distance meter to a torpedo level, and he just shoots the top of the girder. Now, I think this is great for steel girders. I don't know if I would want to use it on concrete girders because the top's so regular, where are you actually shooting? On a steel girder, you need a flat bottom something so you're sitting on that high point on that buildup. But on steel girders, it worked great. So he has challenged me, and now I'm going to have to one-up him. I'm trying to find one of these that you can do like a scale and tear it to where I can directly read the buildup instead of reading that total distance. So there's always ways to improve this stuff. All right.
Cameron, can I interject real quick? You said this, but I just want to make sure it doesn't get overlooked. So what Cameron said is on a steel girder bridge, the top of that girder is smooth, right? So it's very consistent. And we all know on concrete girders, you know, the top of that flange, you know, it's got a rake finish, so it's kind of rough. So it's not going to be the same all the way across. So as you're shooting or measuring down, right, if you use that distance meter, it could pick the high spot, it could pick the low. And if that varies an eighth of an inch, quarter inch, then that's going to give you a false measurement. So we want to make sure that when we're shooting our original shots on top of the girders, when they're surveying that in, to calculate our buildups, right, they should be using a grade rod with a flat bottom. And if there's, let's say there's a little pebble sticking up here and they've got their little paint mark and that's where they took their shot, that grade rod should be sitting on that high spot, right? And that's where the elevation, and that's our benchmark, right? So we need to be measuring down to that exact same spot. So if that paint mark is right there, when we do our dry run, whether we get down and do the soar back method or we use the stick, we should be right on that high spot. If I measure down beside it and it's a little bit lower, I'm not reading the same thing that they use to calculate the buildup. So it's important, right? Now, recognizing that, we've shared this with our materials and test folks, and so what you're gonna start seeing, hopefully soon, they're gonna tell the producers to not rake the whole thing. They're gonna give us a smooth finish here, a smooth finish here, and a smooth finish there. Because when we take our shots here, if that's smooth, we'll get more accurate. And then, you know, sometimes we'll shoot buildups on the outside as well, especially the wide flange girders. And so if we have a smooth spot here, we'll have a more accurate measurement here and here. So you should start seeing that. It'll help us get a little bit more accurate, a little bit better, right?
Okay, now we're going to start our dry run. You want to start at the first 10th point on the exterior girder. And when I do it, I'm going to go all the way down that side, checking every 20th, 40th, 60th point, whatever. I want to check every one of them. And I'm just going to read at this point. I'm not making any adjustments. Then I move my carriage over to the other exterior girder. And I come back down that side, reading every point. Now, the reason I do that is because if I have this line, which represents the grade I'm looking for, and I go down through there, and I'm a little high here, a little high here, a little high here. I got this one low, high, 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 low, low, high, high, high. I can do one of two things. I can go down and adjust that rail all the way down through there. Or, what else could I do to take care of 90% of that?
Average all of them and adjust the whole both sides of the ring.
I'm gonna, if this is me, I'm gonna adjust it in the legs, because whatever you do, the legs does it all the way across this line. So if I can adjust it to get rid of all these up here, then I've only got these 3 or 4 down here. Now it's a whole lot easier to crank a leg than it is to go down through there and raise or lower your screed rail. So I'm just trying to minimize the amount of work that the contractor is going to have to do. But after I do that, if I make an adjustment or not, then I go back and I start reading to adjust the actual rail. And I'm going to go down through there and put it down on the build-up point. I'm going to read to the carriage rail, and I'm going to tell him high or low, how much. What is our tolerance? Zero. If you read the construction manual, the setup guide, it gives you a 1/16 of an inch. That is based on how far apart buildups normally are, and the part of the specifications that tells you when you do your straight edge after the deck's poured, you can only have an 1/8 of an inch deviation in 10 feet. And if you can't make a 1/16 in 5, can't make a 1/8 and 10. The bottom line is it's not a hard adjustment to make. You want to get as close as you possibly can. So if somebody tells you, well, I've got a 1/4 inch leeway on that, no, you don't. If I show up on your job and I ask you for your dry run, I'm gonna pick that thing up. The first thing I'm gonna do is you should have a column for the theoretical buildup and what you actually read. And I'm going to look and see and there should be a column beside that with the difference between those two. I'm going to look at that thing, and if there's any spot where that's out by more than 100th, I'm going to make them go back and fix that. The second thing that I'll look for is if I've got a difference from one build-up to the next of more than 100th, I'm going to make them fix that too. So let's say you've got a bridge where your points are 3 feet apart. And if I'm 100th high here, 3 feet later, I'm 100th low. 3 feet later, I'm 100th high. What have I actually got there? I got a 1/4 inch dip in 6 feet, and I'm going to feel that. So that's the two things I look for. Make sure nothing deviates from this line more than 100th. Make sure that adjacent points don't deviate from each other more than 100th. Now, when you record them, like I said, I like them in a workbook, but I know you guys mainly get printouts from the contract surveyors now. And what Darren has been bringing up is he likes to set it up where you've got your lowest buildup, you're beginning at the bottom of the page, working your way up, so that when you stand there at the zero end and you're looking at it just like it is on the deck. And you can tell if I've got a cover problem or something over here, I can look at it and it makes more sense. If you do it this way, it's a little bit backwards. Those should really be numbered from bottom to top. You notice I've also got the space in there on both of these for my deck thickness and my steel coverage checks. And again, on the exterior girders, check every point. And don't pay attention to anything going on in the middle until you get those exterior girders, till you get your exteriors set. Because any adjustment you make on the side is affecting that screed all the way across. So get your exteriors done, and then you can pay attention to what's going on in the middle. Now, what does that screed rail determine? Your ride. That's important. So we want to be very particular on those exterior girders. In the middle, it's not going to determine your ride. What it will determine if you've got a problem is you may have a deck that's a little bit thin or thick, or maybe you got a insufficient cover. We got more leeway on that than we do on the ride. Okay, so you check the exteriors first, then you check the middles. Now, during the pour, you need to be making depth checks. And that's what David's doing here. He's got his depth checker. The pointy end, he's taking and he's probing down until he can find the top of that deck pan. He can flip it over and take that T-section and stick it down in there to find the top of the rebar. Again, you're the lead inspector. That's what you're out there doing. And how often should you do that? 15 times minimum. That's what I like to see. And that gives you at the 1/4 points and 3 across. Record it. Put it on the sheet. Because if something by chance happens, which shouldn't if we followed all these steps, if you end up having a grind for some reason, and you call Aaron and say, Aaron, I'm going to have to grind, the first question Aaron's going to ask you is going to be, how much cover do you have? Now, it's awful nice if he can... if you can pull that book out and say, well, in this area, I've got an extra 1/2 inch of cover. And Aaron says, okay, we can grind right there. You don't want to have to get M&T to come out with a pacometer. That's the other option. If you don't know what the cover is, they're going to have to come out with a pacometer and check and see if they can determine how much cover you've got. So this is valuable information when you're talking to somebody like Aaron after the fact trying to fix a problem. All right, let's look at a few slides of good and bad. Now, this is a little bit hard to see, but we got an open pitted finish like I was talking about earlier. Now, one of the possibilities here, maybe he's finishing in the wrong direction, which we should have taken care of that already. Maybe he's pushing too much material. That may be bigger than a golf ball right there. I don't care how big that is. Like I said before, if he's finishing good, I'm not going to worry about it. But if he's not finishing good, I'm going to start looking for problems. Is he pushing too much mix? What's going on here? So you got some ideas maybe to talk to him about and see what you're not just guessing. You got some educated ideas on what might be happening to cause the problem that you got. What happened here? On every deck pour, there's somebody out there. So they have a pressure washer or a blow pipe. What do? What is their job supposed to be?
Fog or mist.
Do what?
Fog or mist.
Fog or mist what?
Whatever.
What they're actually supposed to be doing, if you want to get technical, they're supposed to be controlling the relative humidity of the air above the deck. They don't want dry air above the deck, because if you keep a high relative humidity over that deck, then that reduces the chance that you'll have shrinkage cracking due to excess evaporation. You don't want to add water to the top of the deck. And I have been out on pours before where they were just constantly doing this, and I would walk over and say, "Can I borrow your pressure washer?" And I would hold it and wait till I thought they needed it back, because they would just add too much. Now, what's happening when you add too much water to that surface before the screed comes across it? What's happening? It's getting finished into that top quarter inch, right? More water in there means your water cement ratio goes up. Your water cement ratio goes up, your compressive strength goes down. And what does that top quarter inch end up being in the final product? It's your grooving, isn't it? So you start seeing things like grooving snapping off. I mentioned that the guys that are finishing down the sides in the gutter line, there's a couple of problems they caused us. They're also bad to add too much water. They'll have one of those big brushes going down through there, sprinkling and adding water to the gutters. So if you see scaling where that top little layer of grout's coming off, and you can walk right out the front door of this building and see it in the sidewalk, that's what's going on. And I can normally, if I walk up on the deck, I've not even been on the pour, I can show you places where you put too much water here when you're finishing, because it causes that defect. All right, let's look at some problems. What's going on here? We're starting to leave this ridge back here. Now, why could that be? We've also got a bit of an open pitted finish in here. We're doing that. We've got a ridge developing behind the drums where we don't want it. So what would you think you might be able to do to help this? He may be getting too much mix back. That looks like a loaf of French bread. Does not look like a golf ball size. So maybe he's getting too much mix back to his drums. Could have something to do with mix consistency, but we're looking at the screed. So maybe he needs to lower those augers a little bit. The other way that you can get rid of a roll back there in the back is raising the back legs. And we'll look at that here in just a minute. Here's another extreme example on the latex overlay. A lot of mix getting all the way through those drums. So one option is lowering your augers. And again, once you lower those augers, don't make another adjustment until you go about 4 feet. This one looks pretty good. Now, one of the things I point out on this slide is you got this little dry patch back here at the back of the drums, and the rest of it's wet. What that means is the majority of that drum is in contact with the surface of the concrete. It's finishing. It's doing its job. But that little back end right there where it's dry, it's not touching the concrete. That's a place, if your drum is entirely wet and it's touching all the way, that's where you may see some mix coming out the back, some grout coming out the back. So maybe in those slides we were just looking at, if they're not getting too much mix back into the drums, maybe they just forgot to crank the back legs up a little bit, or they need to raise them up half a turn and see what happens with that. So you guys know some things that he can do now. There's another pretty good setup. Looks like they're getting a good finish out of it. What is that? That's a broom. That first deck pour I referenced earlier. Went out there. I have spent an hour and 20 minutes of my life telling you guys how to set this machine up properly to let it do the work for you. That first deck pour, the machine went across, and the first thing that happened, they pulled the work bridge out there, a guy gets up out of the bull float and goes back over the entire deck surface. Why? We have taken great pains to set this thing up correctly so it does the work for us and gives us a good job. Why hit it? The only reason to bull float or bring back there really is if somebody falls off that work bridge into the concrete. Then you might need it. But otherwise, we shouldn't have to do that. Right here, you're back there and you're checking, making sure, keep an eye on this guy, making sure that he is cutting that same rate that the screed's cutting across through there all the way to the gutter line. Be nice if that straight edge was a little longer. And you see right behind them, they're coming back covering it up. That's just a picture. They make a misting system that you can put on these things. Now, I like this picture right here because they're right behind the screed with the burlap. Now, years ago, the philosophy of a lot of the foremen was, I'm going to pour this deck, I'm going to go eat a sandwich, I'm going to smoke a cigarette, I'm going to talk to the guys, and then when the deck is stiffened up enough to where I'm not going to mark it, then I'm going to put my burlap down. That's not what we want to do. I am far less concerned with having the pattern of the burlap in the top of that concrete or seeing a mark here and there than I am with shrinkage cracking. Because shrinkage cracking is always the contractor's fault, according to the spec book, and you're going to have to do a patch or something similar to fix it. It's a defect, and we don't want it. So I like them being as close as possible. Now, what kind of burlap are they putting down here? Wet burlap. When do you wet it? You wet it the day before. If you wet it that morning, this is what you get. It's got this zebra pattern. You can't wet the burlap that day or you're not going to get it wet. So they have a kiddie pool, a stock tank, something that they rigged up, soak it overnight. Then the morning of the pour, you want them to take the burlap out and start stacking it on the work bridge. The other extreme that we can have besides dry burlap, which dry burlap will suck water out of the deck, we can go the other extreme. Once they put that wet burlap on the work bridge, you want to let it sit there a little bit and drip out. I also like to see the contractor taking the burlap off of the work bridge and setting it ahead of the work bridge. Because this one, they didn't let it drip out. They were setting it behind the work bridge, so all that burlap's just dripping on the deck, making defects in the top of the deck we've taken such great pains to produce. Okay, back to skewed decks. As I said before, between 75 and 105, the contractor may set his screed up on a 90, and he may pour that way. He doesn't have to, but once you get outside of those bounds, he has to set it up on a skew. So if we allow that, what's wrong with this picture? I outlined it for you. What is it? Well, he's not got his screed on the skew, and he's not loading the concrete on the skew. If we allow them to pour it on a 90, we still want that concrete to be loaded on the girders on the skew. And you can mark your rail with a can of paint at the build-up points, however you want to do it. And keep an eye on them, because they'll normally start out fine at the header. They're just following the header. But the further they get away, they start trying to square it up. So you want to make sure that they get loaded evenly, because in this situation, you got this girder over here that's already started deflecting, where the screed's already out there, and then you got this one that's still on dry ground, but you're going to have some differential deflections that's going to make life a little harder for you. So you always want to load on the skew. One of the things I don't like a great deal is loading way far ahead of the screed, because that guy on the hose, he has trouble telling how much concrete he's put out there. And that can make a difference in them guys that are raking themselves to death, or just doing a normal job, or having to go back and shoot some more concrete in low spots. So, all right, skewed deck. If that mean designer that I was talking about earlier, if he designs this bridge deck with a crown and a skew, then you have problems. This video explains what they are, and it's the fix is not as simple as just setting the screed up like you normally would and skewing the bottom of the carriage and going ahead, because this will explain it a little bit. All right, this is my screed model. Those pencils are supposed to be the drums, and that's my truss. And you notice that as the carriage crosses the crown, that the pencils stay parallel with the deck, like we want it. Now, if we just twist the bottom of that carriage around on the skew and keep everything set up the same, watch what happens when he crosses that crown point. Look at the front of the drums. They take a dive. And you can stand back at the end of the screed watching it as it crosses the crown point, and you'll see it do that. That will round off your crown point, which can cause problems with joints and things like that. And it will also eat your header up on this side over here. So you're going to need an extra piece of equipment. Now that's supposed to represent the skew bar kit, those pencils on top. All it's doing is moving where that carriage is supported, so that both of the front wheels and the back wheels, they cross the crown point at the same time. And you notice as he crosses that crown point, the drums stay parallel to the deck. Okay, now the red lines here, that's a skew bar kit. Like I said, all it's doing is it's taking a wheel that was here and moving it out here, taking a wheel that was here and moving it out here. The other thing that we're doing, you notice that my center line, my crown point, is hitting different places on each side of the screed. So I'm going to have to break this side of the screed here and this side of the screed here. In order to do that, you can get a special length section so that I'm looking straight through that thing. Those are the 2 points at which I'm crowning that truss. They're not 90 degrees across from each other like you see right here. And if you look at it from the top, it looks kind of like this. And this is all a skew bar kit is. There's not a whole lot to it. Depending on the manufacturer, they may look different, but it's basically a big piece of channel with some extra brackets. You can make one in your garage if you wanted to. Now, this particular bridge that I've taken these pictures on, we have had a barrier wall contractor that I don't think's working anymore that did excellent work. And the owner, he was, we'll say a little bit grouchy, opinionated. He came to this deck. The contractor followed everything in the instructions. The skew deck setup, the skew bar kit, the regular setup instructions. He followed every bit of it. That gentleman pouring that barrier wall came out to that job. He walked over to the inspector after he got done setting up, and he said, "That's the best deck I've seen. I had to adjust my string line less on that deck than I have on any deck I've ever done." Now, coming from him, that's high praise. It proves that if you follow the directions, you will end up with a much better product. This is a view from the inside. You can see this is a skew bar kit. Again, it just moves where the wheels are at. Now, when you're pouring on a skew, one of the things that you need to bear in mind is how much finishing area are you getting out of those drums. And at each end of with each pass, the screed's going to move ahead a little bit, right? Now, how much that contractor has set that screed to move ahead, it varies. And unless he starts getting a bad finish, I'm not really going to worry with that either. If he moves ahead too much at a time, you can get kind of a washboard finish. Also, when you are, so if this is my drum, the shadow of that drum is about the same length as my drum, right? But as I start turning that, even though my drum length didn't change, my shadow gets shorter, right? Same thing's happening on finishing this. With that drum being turned at an angle, when you're looking at it from the side here, it looks like you're getting less finishing area out of it. So one of the things a contractor may have to do on a very skewed pour, he may have to shorten up the travel distance in between passes. Another view from the inside. And this is a good shot showing how much, on a real bad skew, how much it diminishes that finishing area. All right, when you're setting up your drag pans and your burlap drag back here on the back, if you're on a skewed pour, this rack that holds them, it has to be connected to the bottom half of the carriage. If you're on a 90-degree skew, you can attach it to the top half. But if you attach it to the top half on a skewed pour, it's going to end up jamming in to your barrier wall steel. So skewed pour, that mounts on the bottom. You'll also notice that your pans are twisted so that they are squared up with the direction they're actually moving. They're not squared up with that frame. You want them squared up with the direction it's moving. So that whole front edge is in the same position. You don't want a corner sticking out that could dig in accidentally. Same thing with your burlap drag. You want it skewed to where it's squared up with the same direction as travel. And that keeps it from wadding up and leaving marks behind you. So what have we learned?
Everything about second
Learn more than you're going to remember, but you got resources, right? You know I've got videos I can go to. I'm going to have a copy of this I can go to. I can print directions off. I can call Aaron Earwood anytime I need to, and he will be glad to help me out. Maybe even come visit me, right? But one of the big things is there are directions. Follow them. It was the last time you activated the fertilize function without reading the directions first. Bad things can happen if you don't follow the directions. It's simple. My son couldn't even read, but he could follow those directions. Okay? Anybody got any questions about any of this? If you don't know what's wrong there, I'm not going to tell you.